As you can see on many popular YouTube channels, a good way to reduce heat under the hood is to remove the entire hood. That's not very practical, so in this video we will take a look at which various materials react differently to under hood temperatures. So take a look with us when we test steel, aluminum and fiberglass for those properties.
So what do you actually want from the hood of your car? It may sound like a silly question, but the hood of your car does a lot more than just covering up the engine. And there's a couple materials you can choose from when you have a hood on your car. Most cars will have a steel hood, but there's also cars with aluminum hoods. Many BMWs have aluminum hoods, and obviously for racing and drifting a lot of people use fiberglass or carbon fiber hoods. And one thing that most people seem to forget is that the material of your hood has a lot to do with the cooling capacity of your car. And the reason for that is because these different materials have different ways of emitting heat. So some materials let heat pass through very quickly, like copper or aluminum. Other ones a little bit less easy, like steel. We're going to do a little experiment with that. We're going to use some water, and we're going to be using the exact same amount of water for each test. So that's this thing that gets filled up completely, which is 50 milliliters right here. And we'll be using a test setup. This is a plate of steel that we will be heating from underneath. We also have a plate of fiberglass over here, and we have some aluminum plate. The aluminum and the steel are exactly the same thickness. The fiberglass is a little bit thicker. And what we're going to do is we're going to see, by putting some heat over here, how much of that heat is going to travel into this bowl, which is going to be containing this amount of water. And by testing the temperature, we're going to find out how much of the heat from underneath is actually going to pass through. And the temperature of the water is going to be the same, because we're going to get new water from this little jar. And this is going to be the exact same setup. We're just going to be changing out this little piece. There's a heat gun under here, and that's going to be heating through the material, and we're going to see how much of that heat comes through and how much it heats up this water. The water to start with is 5.6 degrees, 5.5, 5.6 degrees. So that's the base of it. And then the material over here is, this is, let's say over here, over there. So let's take a couple things. So this is, yeah, this is also like, this is almost the same. So this is 5.5. So the temperature of the water and the temperature of the piece is exactly the same when we start out. I'm going to use my phone as a stopwatch. So we're going to use exactly the exact same amount of time. Let's hope it happens a little bit quick. Otherwise it's going to be a long video. So we're on the steel piece. Been heating this. I've waited for the thing to reach temperature, and then I aimed it at the plate, and we're running now for 24 seconds. And we're still here at 5.8. So it didn't do much in 40 seconds. So the plate is actually warming up. So the plate is right when exactly where the heat is coming. It's on 14, 15, 16. So that's climbing. Now on the water, we're over 6 now. We're 6.3. So after 2.5 minutes, the water is on 7.4 degrees. So in 2.5 minutes, it went up about 2 degrees. We got 2 degrees Celsius extra on the water. And we actually gained almost 30 degrees on the steel right there. And that's after 2.5 minutes. So let's see what happens if we put 2.5 minutes of the exact same heat gun in the exact same position, because I marked this over here, and see what happens if we put that on the aluminum piece. So we're going to do exactly the same thing over here. This is going to get taken off. I'm going to throw that away in a little bit. There we go. So now we have the piece of aluminum in place. We've refreshed the water. This sits on exactly the same level because it sits against a clamp. This is clamped exactly the same way on the table because I marked it over here. This thing hasn't moved. So there we go. And I said this is on 5.5 degrees as the starting point. Let's see what happens. And over here I actually have the fiberglass piece that we're going to be using, which is a little bit thicker than the aluminum and the steel because I couldn't find a 0.8 millimeter piece of fiberglass, obviously. And this is actually the part that we cut out the hood of the sedan car in order to make the scoop. So that's actually going to be very accurate for testing purposes. So we're on 38 seconds now. Let's see what's going on. Yeah, we're already, so this plate is already heating up very quickly. So now you can see that the temperature on the outside of the plate already is 63 degrees after 55 seconds, 56 seconds. So that's very, very fast. If we take a look at exactly this, over 100 degrees now. It's actually over 100 degrees right where the gun is pointed at it. So that's increasing a lot more than the steel plate. And the steel plate was 35-ish. So there, we're already on 8.2 degrees on the water. After 1 minute and 22 seconds, the water went to 8.2 degrees. .7, and the aluminum plate is, yeah, that's heating up. So it's like over here it's almost 80, and we're, yeah, this is like, yeah, we're on 9.9 degrees after 1 minute and 50 seconds. The water is already at 9.9 degrees, which is much higher than it even reached ever on the steel hood. The edge of the aluminum now is 84 degrees. 83, 82. Yeah, this is now 11.3 degrees Celsius after 22. Let's see, we're actually on, and right now, yeah. So let's take a good measurement all over. So this is 11.4 degrees water temperature after exactly the same amount, 2.5 minutes. So we actually gained, like, we went from 5.5 degrees to 11.5 degrees on the aluminum in 2.5 minutes. Exactly the same thing. And the material actually is like over here, right here on the edge where we measured it. It's 75 degrees. We didn't measure it immediately, so that's 75, and the steel was around 35, or it was like 35. So that's a very, very, very significant gain over there, which tells us that the aluminum transfers much more heat than the steel. So if you have an aluminum hood, you're absolutely going to have a lot more heat passing through that hood. So the heat source is always going to be there, which is your engine, and it's going to pass through the hood just like that. Now for our final piece, I already put some of this in, so this is the rest of it. So that's 60 milliliters of cold water that's going into this setup. And just to measure it, it's, for some reason this is on 6.5 degrees. So now maybe the temperature over here went up or something. But this is 6.5 degrees to start with. The other two were 5.5 degrees. Yeah, so that's it. And this, the fiberglass piece over here is on, let's have a good measurement over there. Yeah, there we go. Yeah. So that, yeah, so that's the same as everything else. So that's 5.6 degrees on the fiberglass piece. Let's measure the water one more time. Yeah. There we go. Hold on, just keep going. We are on 7 degrees on the water. 7.7 degrees after 1 minute and 24 seconds. Over here the fiberglass is reaching 30 degrees. Over there on the edge it's still 7.5 degrees. Water temperature went up to 8.3 degrees. 8.4 degrees after 2 minutes and 15 seconds. 8.6. And we are on approaching 2.30. So that's, yeah, so it remains on 8.6, 8.8. So we're at 8.8 after 2 minutes and 30 seconds on the fiberglass piece, and the piece itself here on the corner is 36 degrees. So also 2.5 minutes, we went to 8.8 on the piece, and we went to 36 degrees on the edge. So what we can see from here is that the aluminum conducts heat much better. Because the water already reached 11.5 degrees Celsius after 2.5 minutes. And the fiberglass, it actually also transmitted some heat. It made the water go from 6.5 to 8.8 degrees. So that's roughly a little over 2 degrees. And the steel actually also gained that. The steel also gained 2 degrees from transmitting the heat. So it transmits heat a lot less good than aluminum. So that's interesting. Obviously the most heat we got in the plate was the aluminum plate, which reached 75 degrees on the exact same edge, where the fiber plate actually was like 36, and steel was, I believe it was around 35. And the materials all started at the exact same temperature. They were all 5.5 degrees, and for some reason when we did the test with the fiberglass, the water temperature was a little bit higher. So this tells you that if you run a steel or a fiberglass hood, there's actually going to be a lot less heat transferring through that hood. So an aluminum hood would actually be the most perfect thing, because all the heat that's coming from underneath the hood is going to get passed through. So that's the point of this whole test. And yeah, let me know what you think.